Hey class, welcome to the vlog for week 2. This is my first vlog entry. There wasn't a whole lot of stuff to talk about this week, but I do have a few things that I appreciate the chance to talk to y'all about. So just firstly, thank you for everyone who filled in the introduction poll over the last few weeks. It really helps for me to get to know you a little bit and to hear what you want to get out of the course. And it's tough doing things online, so it's nice to get a little bit of a sense of who you are. So thank you for everyone who introduced themselves there. I did read them all. I didn't respond to them all, but I did read them all and take notes on them. So hopefully you'll see some of the things you talked about being talked about. And if they're not being talked about enough, please put a vlog request or a feedback on the forum and let me know what I can add to the course for you to make it more interesting and educational. So another great way to get a little bit of face-to-face time, which I think is important for educators to have with students, is through office hours. So we had our first office hour today. A couple of people came, but I just wanted to show everyone how to actually get to it if you're curious how. So on Microsoft Teams, which you all should have now, if you go to, you should all be added to a team for this course. Let me know if you're not. If you go to the course team, then there's a few different topics in here. So Ben's got one set up for the labs. So if you go in here, this is where you'll be able to get into the lab help sessions. So the first one is this week, looking at the first chunk of lab 1. And there's one in here for office hours. So it'll be the same place every week. I'll just be in here for the hour, which is 1:30 to 2:30 on Tuesdays. So just drop in about anything. You can have specific questions. You can just say hi. You can have suggestions, whatever. That's what that time is for. And I really appreciate the opportunity to meet with you all a little bit face to face as much as possible through that. So one of the questions that I got in the office hour today was around one of the questions on the first progress quiz about calculating life cycle net benefits. And this course in a few places, it kind of brings in knowledge that you might have already. If you don't have it already, it's good to ask about it. And that's kind of what we learned this week. So you may have seen this kind of calculation before. Really simple. So here's a similar example. In year 1, I've got a cost of my investment, and then throughout the project life, in this case it's 4 years, I have a bunch of benefits. So it could be I spend money in year 1 and then I get revenue in all the other years. It could be I have a greenhouse gas cost in year 1 to buy something, and there's a cost associated to produce it, and then I have benefits in all the following years. Works for either. So I have a one-time cost and then a few annual costs. So the way that we can actually compare those together is either by annualizing all the costs and comparing them on a yearly net basis, or adding all the total costs through the life and comparing them on a total project basis. So to demonstrate, this approach would be annualizing the cost. So instead of one big cost of 10 in the first year, I've spread it out. So I have a little cost of 2.5 in each year. And then similarly, my benefits, I had a benefit of 4 in the last 3 years. I've spread them out across the project life evenly. So I have 3 across 4 years. And then if you want to look at the net benefit each year, 3 minus 2.5, your benefit is 0.5 each year. Or if you wanted to look on the full project basis, 0.5 times 4, so a benefit of 2 in the end. The way you can do it by just adding everything together to look at the full project, instead of dividing by the project life, I've multiplied by the project life. So I have my one big cost here is still 10, and then my benefits of each year, the 4 over the 3 years are all added together to 12, and now the net is still 12 minus 10, which is 2 over the project life. So this is like, you can get more complicated with these models. This question is just to get you used to the idea that while life cycle analysis is also like a qualitative tool that we use just thinking about things, and that's mostly how we'll do it in this course. You can also be quantitative about it. We're not going to go super into detail, but just to practice that a little bit. So that's what that question's all about. Another way we can have a bit of face-to-face time is built into the project. So I've built the project with a few milestones, so I have a chance to look at your work and talk to you about it and kind of answer any questions you have and maybe provoke you to think about things in a slightly different way or things like that. So I'm looking forward to those opportunities to meet with you as we work through the project. So each milestone, as you get a little bit closer, I'll be reviewing and giving you written feedback, and then I encourage you as well to set up an appointment to chat with me about your feedback as well. So I'll put a process to do that, but I'm hoping to kind of talk with you a little bit more and help guide your learning. It's tough to do online, so the project is a way I want to use to kind of have a little bit of more nuanced discussion about your interests. And yeah, I'm looking forward to getting your submissions next week on that. And then the lab, I just want to mention, so I showed you how to get onto the lab help session. With the lab, it's a little bit funny, the sequencing, just to be able to spread everything out in the course. But we're talking about landfill gas modeling in the lab, which seems like a little bit premature because we're still at the top of the waste hierarchy. We got to work our way down to landfills. But next week, we're going to start looking at organic waste. And this is where landfills and something higher up the chain, like anaerobic digestion, really come together, because biogas from an anaerobic digester and landfill gas from a landfill, they're really the same gas coming from the same process. We just capture them in different ways. So I think that some of the thinking we'll start doing in the organic waste unit will lend itself a little bit, especially to the early parts of the lab. And then as we get more into the landfill, it'll fall together a little bit more. So hopefully the sequence kind of supports itself. And if you have questions like about landfills that you feel like we don't have enough background on, I can definitely give you some more content. You have all the course notes too, so you can scroll through to the bottom to the landfill section if you'd like to. But that's kind of why we're doing the lab now, just to spread out the work, and because it fits in with the organic waste, the idea of biogas, anaerobic digestion kind of goes together. So I just wanted to touch on that so you know what's going on and don't feel too disoriented by that. And then the last thing I'd like to look at in this vlog is a news article. And if you come across any news articles over the week that you want to share with the class, just send them my way and we can take a look at them. So this is an article headline from CDC, headline, government quietly made backdoor agreement with US that could undermine treaty on plastic waste. And in the picture here is activists in the Philippines. So you might remember from, it was several years long incident that happened 2013 to 2015, where Canada had shipped a bunch of very contaminated recycling, which people just called garbage because it was so contaminated, to the Philippines. And the Philippine president told them, take it back, we don't want your garbage. And it just took a long time to work out. And it kind of underscored this issue of the kind of global north countries exporting their low value recyclables and them not actually achieving the dream of recycling to support the circular economy, but being dumped in the ocean or open burned. So it would have actually been better for that plastic to be landfilled in Canada in like properly designed landfill rather than exported and then improperly treated in a legal facility. So kind of exposed the lie of recycling, and there's been a lot of reporting on that, and we'll definitely get into that. One of the things that's kind of interesting about this agreement that it's talking about, so the Philippines issue is earlier. What's happened now is that Canada has made an agreement with the United States that allows them to export plastic waste to the US, which appears to be counter to this international convention we have that prevents the movement of waste. So this is called the Basel Convention, and I'll send the link for this. This convention was made to stop the shipping of hazardous waste from the global north to the global south, because countries used to say, well, I don't want to do anything with this waste. Let's just, send it to some poor country and dump it on the beach. And that happened back in like the 70s and 80s. So this convention was made to stop that. And recently they added plastics to it because of these types of issues. And it appears to be something that Canada's kind of trying to find a way out of, because we do have this problem. We have a lot of low valuable recyclables that we can't necessarily use in Canada. We used to ship a lot of them to China. Then China passed this policy, the National Sword, which stopped it. And then our waste kind of hopscotched around different Southeast Asian countries who would start accepting it, and then it would get shut down by their government. So it kind of has exposed this unsustainability of recycling low value and highly contaminated streams. So this comes back to what we were talking about with waste reduction, waste diversion. So if we can design products that are actually going to produce a recycling that's higher value. So aluminum cans, for example, the most valuable recyclable commodity. Plastic film, no one wants it, really hard to do anything with. If we could put more things in aluminum than plastic film, for example, then we'd have more incentive to recycle it and we wouldn't maybe ship it off as much. Also underscores this idea of reduction versus diversion. Hopefully I drove it home in the videos on that unit, but diversion could result in something like highly contaminated, low value recyclables getting shipped overseas as it has. So recycling is really not the answer. Diversion is not the answer. Reduction is the answer, or reuse reduce, reuse, recycle, right? So those first two are really the key ones. Even if we recycle, then we can still have consequences like this in our current system. So yeah, most of the rest of the course, we're going to be looking at more of those disposal technologies and getting into the engineering of them. But please don't forget the importance of reduction and elimination before you even get that and before you even get to diversion, because even diversion is dicey at times. So hopefully Canada improves its leadership on this. Domestically, we're doing this plastic waste ban. So hopefully internationally, we can also be kind of someone who's a leader in the space. But we'll see what the government does and what they choose to say is important. So that's that. If you've come across any other interesting articles about waste or waste related, energy related, greenhouse gas related, whatever, let me know and I can share them in this kind of format, or we can share them on the Learn forum or whatever. But that's all for now. Till next time, please feel free to reach out on Learn or come to office hour or whatever else. And I look forward to chatting. Bye.